Hey guys, and welcome back to the FRC Coding Class Day 8. Today we're going to be getting into more specifics of our code base for Team 5104 and separating from the more generic stuff across FRC. So we're going to start off with the code structure and flow. We only have 2 classes left, including this one. So next week we'll cover writing subsystems. I'm not including all the information you need to write code, basically from knowing nothing to the full implementation of the 5104 code base and all the different FRC code. But it should be a great standpoint, and some people on the team know a little bit further on, but it's going to be a lot of detail, and I'm hoping that you guys, a lot of it's intuitive, and if you can't figure it out, feel free to contact me, and I should be able to help out with a lot of that stuff. So, first off, basically everything I just said. We have made a comprehensive layout, so most teams don't have as extensive as a layout as we have. Our goal, we've been messing around with them for many years, and because we've had such terrible layouts, we've decided to make a really extensive layout to give a clear, just basically clean up our code, make it easy to debug and navigate, and have it kind of same across all the robots. So if you understand how to code for one, you kind of understand how to look at code for all the others. This class will not cover GitHub. GitHub is basically a tool where you can, I guess it would be like making your code to Google Drive, but for your code. So you can go back and see different changes you've made across time, who made them, and sync it across multiple computers through the cloud. We're not going to cover how to do that, but they do have a great website, and you can view all our code from 2020 and from all the other years. I put the link right here. This is to our 2020 robot, and I'll be referencing most of the stuff from there. First, I'm going to start off with the code structure. So this is what it would look like in Eclipse, which is where you're editing the code. So packages are these little brown boxes right here, and they basically help separate the different files into sections, and I'm going to be covering what the different sections mean. So frc.team5104 contains robot.java, which is where the code, or where you can think of basically the code starts. The program starts, maybe you have a main.java and different code, kind of a similar thing. And I'll talk more about it in a second. Superstructure.java is basically a giant state machine for the robot. So if you ever want to know what the robot at least thinks it's doing, the superstructure will always know. So is it trying to pick up a ball? Is it trying to shoot a ball? Is it trying to spin the control panel? It'll always, it stores all those states basically. Controls.java contains every single button and axis that is used to control the robot. So basically, it concentrates all the different controls for the robot. If you want to know, what's the button to shoot the ball? I just look in controls.java and it'll say like shoot button B, and it just makes it super easy for changing the controls, reading the controls, and it's just nice to have it all in one location. We follow that logic with ports.java, which is basically every single port or device ID that is on the robot. So CAN IDs, sensor ports, etc. Literally everything will be in one place. And again, we have the same thing for constants.java. So common constants that you would tune, like PID values or motor speeds. Basically, our goal is to not have a lot of these constants stored inside the subsystems, because it makes them a bit messy, and it's nice to just have them all kind of in one place. So if I am changing all the ports for a new robot, for example, it's all in one place instead of having to go into which subsystem is this sensor in, because sometimes there's some gray areas. Like I said, I'm going to cover robot.java a little more extensively. So basically, there's a bunch more code, but this is really all you have to deal with is the public robot constructor for it. Basically, you probably be editing this day to day. Like if you're tuning the robot and you have all the subsystems programmed, you will be mostly in here, and maybe in constants.java and the subsystems themselves. So the first, probably most important part right here is subsystems manager.use subsystems. Basically, you'll put in all your subsystems here, and then you can comment them out, which basically takes them out completely. So whatever subsystems you put in here will get run. Any subsystems you don't have in here just will not get run. Like they'll still exist in the code, they just won't get any of the methods called. And this might cause issues if your code is set up in a way that certain things rely on a subsystem running. So let's say, for example, the shooter won't start actually shooting the balls until it, let's just say the turret says it's on target, like the vision system says it's on target. And if I disable the turret, the shooter just will never shoot now. So you'll have to look out for that. The following method, teleup controller manager use teleup controllers, is the same thing but for teleup controllers. I haven't covered that, so I'll cover that a little later. Down further, down here is auto manager.set target path. Basically, you can just put in whatever path you have made. I'll cover briefly what auto paths are, but not too much. And you can select those here. Down at the bottom is a sort of new feature. I'm fairly certain nobody has used this. Subsystem manager.debug. Basically, if I'm working on tuning the turret or the hood or the shooter, I'll just put in the name of that subsystem. So let's say, for example, turret with a capital T, no new or parentheses or anything, just turret.class, and then you separate however many you have by commas. Kind of like this. So instead of saying new turret up here, you say turret.class, because we already have a version of turret. This is the global version of turret, and so I want to reference that version instead of making two turrets, which would really mess up the code. Okay, FRC .team5104.auto is all the files that run the auto. There's two subfolders. So paths, I'm going to cover this quite briefly. Basically, an auto path is around a 15-second list of actions. So it's a sequence of actions. It'll be like drive here, shoot, drive here, intake, drive here, shoot. That's basically what they are. That's what the path is, and then an action would be like intake, shoot, drive, etc. So auto.actions stores all the actions, auto.paths stores all the paths, auto.nothing is like kind of general setup for the auto, and you probably won't have to be messing with that, hopefully. .subsystems contains each subsystem with a single file per subsystem, and I'm not going to go into depth because this is all what next week's class will cover. .teleup contains teleup controllers, and basically what these are they're super simple classes. We only have 3 of them, and we probably will only ever have 3 of them. What they do is they run during teleup, and they convert user input from controls.java into changes in subsystems or superstructure.java. And basically, I mean, this is literally what it is. There's a loop, there's a function that gets called repeatedly, and inside there's just a bunch of these statements. If this button pressed, tell the superstructure that button was pressed, basically. This might seem quite dumb, but it gives us a little bit of abstraction, because this runs during teleup, and then when we're in auto, we just replace teleup controllers with the auto controller. .util is something super useful. I'm just going to pull this all up here. It contains a bunch of files for basically random things that we don't want to rewrite. The goal is that you can use these files multiple times and all the code's done for you. So a big example that we use a lot is console.java. Instead of saying system.out.println, console.java is a whole class that will give you logging, but with special features. My goal is to make it a lot like console.log in JavaScript, if you've used that, because I just kind of like it, and also it gives us a ton of other benefits. For example, telling the timestamp of when something happened, it'll add it to every print statement to a log file to review later. Basically, if you're going to try to print something out to the console, do it through console.log. We also have like console.error and a ton of other things you can look through in there. Breaker math is just a bunch of simplified math functions. Xbox controller, we wrote a class on top of a class written as a base FRC class, basically to give us more functionality with the controllers, like double clicking, holding the controller for X amount of time, and special deadbands and curves on the axes. I'm not going to go into that. Basically, it allows more complex user input as well, say. Moving average and latch boolean are probably the other common ones you'll see. Basically, these are other math classes, and they help you simplify things. Moving average would be like smoothing out sensor input. I'm gonna stop myself before I go into detail about that. Code flow. Basically, how does the data move during tally up? So obviously, the data would start at the Xbox controller. And actually, this is written a little incorrectly. It starts at the Xbox controller, which then goes into controls.java. So this should actually be called controls.java. But basically, you have your tally up controllers, like I explained, and these read data from controls.java / Xbox controller. And so let's say for the drive example, drive controller, for example, it'll read data from here, and then based on what it read, maybe is the shift button pressed, then it'll call methods inside drive.java. On the superstructure, however, it's a little bit different. So basically, it reads data. Based on that, it'll call stuff in superstructure, and sometimes it'll call stuff in subsystems. But the other thing is, as I said, the superstructure stores all the states for the robot. Am I picking up a ball? Am I shooting? So the superstructure controller will tell it, you should be shooting now, or you should be intaking now. And so the subsystems figure out what the superstructure says they're supposed to be doing and then act accordingly. Again, I'm going to cover how that all works in the subsystems next class. In autonomous, it's a little bit different, although actually quite similar. Instead of having the controllers or like a Xbox controller or anything, it just is all handled through the auto manager. And so it reads the selected path and handles all the logic. It's just a magic black box. Not really, but you can think of it that way. And it calls the current action, and the current action then says, hey, superstructure, you're intaking. And then again, this subsystems can read that, oh, I'm supposed to be intaking, or they might just directly call the subsystems. Okay, so that's how data gets moved, but there's not just data, there's also how do methods and update functions get called. This is not super useful, but you can think of it as starting again at the robot.java, and that'll call the auto manager, which will handle all the auto manager stuff. And then you could also call superstructure and subsystem manager, which then updates all the corresponding subsystems you have enabled, and telling up controller manager does the same thing. Okay, I'm not sure how long this class was, but I think that gave you at least a brief introduction. I don't want to go too into detail and just give you this useless information because a lot of this, I feel like, at least for me, maybe your understanding is more than I would. A lot of this makes a lot of sense with experience on the robot, and that's something which really sucks, but you can't really get a grasp on that. So hopefully, we might get into the shop sometime soon, and you guys can get some more hands-on experience and pick up this knowledge better.